Hello and welcome everyone. Thank you for joining us for today's live stream. Today's topic is unlock generative AI value for Azure cloud practitioners. I am your host, Peter Van Alexam, and I'm the Director of Marketing here at Cloud Institute. And if you're not familiar with Cloud Institute, we're a custom training and coaching company that equips teams to deliver on IT projects. Coaching with cloud experts and hands-on training to help you with those live. And I'm happy to introduce one of those experts. Bring him up here on the screen. We have Zaki Medina, our cloud leader. Zaki, how you doing?
Hey guys.
Zaki, he's an expert and cloud coach who's coached thousands of aspiring scientists and engineers. But before I turn it over to you, I want to encourage you all to please questions in the comments. We'll answer them at the presentation. Also, this recording will be available here on the LinkedIn event page immediately afterward. You can check it out there. And if you'd like a copy of the slide deck, leave us a comment and we'll see if we can get that over to you. So we're going to shoot to keep this to just about 30 minutes or so. But without further ado, I want to hand it over to you, Zaki. Take it away.
Thank you so much, Peter. Well, good morning, good afternoon, good evening, wherever you guys may be from. Just want to make sure if everybody can see my slide here. There you go. Amazing. So quick background about myself. I actually am a self-taught data scientist. Been working on AI for the last several years. Actually had an exit in responsible AI startup a few years ago. Working predominantly in the Azure ecosystem around AI. Now focused on healthcare and working more on the hardware wearable side of AI as well. So, I've looked after teams of developers and cloud and so on. So any questions around that would be more than welcome. But today we have a great agenda. This is the beginning of our generative AI series. Maybe it's a series, right? We'll see. We'll talk a bit about sort of the 101 of Gen AI, really demystify that trigger word for some folks, as well as talk a bit about what the company that really did start Google actually built the technology for it, and then OpenAI ended up productizing it better than them, and then their partnership with Microsoft and so on. And then we'll talk about how Microsoft's leveraging their partnership with OpenAI to bring in generative AI into their service catalog, into their resources, into their cloud resources model. A little quick recap and Q&A. And I'm also very eager to, quick housekeeping rules. Do ask questions. We'll go through questions because of the nature of the presentation, the short time frame we'll answer Q&A at the end. But do pop up those questions up here, so we'll prioritize them. And then at the same time, if you have topic at the end, something to think about. If we are looking for new topics to discuss. If you feel you like the Gen AI theme, do let us know what other topics you'd like to see in this. So without further ado, let's jump in. As I mentioned, AI has been around for a while, especially generative AI. I'm not really going to talk a bit at length about AI. I think we all understand AI is a huge topic. In fact, there's a great book by Pablo Plata Dominguez, that talks about the several tribes. There's like 13 tribes of AI. Great read. So AI is more, it's obviously machines emulating human behavior, right? To learn, perform tasks without needing any kind of explicit instructions or code. Probably that's the right word. And then machine learning is a subset within that. And it's really, they refer to systems that can learn by themselves. That means they code themselves. And what we do is we show them data, we show them examples, and they can take that, machine learning models or algorithms can take that data and fit that data into an algorithm and then create that algorithm, and then that would be the code that they create, and then that could be used to do things like make predictions, how much money a store might make, or a forecast, and so on, or what's the next pattern that comes up based on a series of examples it's been it learned on. And then we have deep learning, which is now even going even further. It's another subset within machine learning, and is based on this concept of artificial neural networks, right? Learning process is deep because the structure requires multiple input, outputs, and hidden layers. All this means is, hey, we're going to feed this model some data, and then it will then figure out what it needs to do for the next layer. Now, this ends up being very large, massive data sets, and within deep learning came about generative AI, and it's another subset within deep learning, right? That can produce new content based on what's described in the input, right? And that in the collection of Gen AI or generative AI, I use the word Gen AI, can produce things like wonderful things like language, code, images, video, audio, and we'll look at some of these in greater detail as we go forward. So, as I mentioned, from an AI model perspective, you're looking at input, right? Past data, examples. We use this concept called features, right? Feature engineering, which is, it's just a fancy buzzword for saying, hey, I'm going to bring a domain expert. The domain expert understands what this data means, and they're going to label it, in those cases, annotate it, right? And it will make sure that this dog is a dog, and maybe it's a Siberian Husky or an Alaskan Malamute, whatever it is, or a golden retriever, and it's a dog, and then that will then get fed into a model, and that model, guess what, is gonna come in and predict the type of dog breed, as you guys know, I'm a dog lover here. So, and it will tell us what that new dog image would look like. That's the new data, right? So we're feeding it data, and it will react on that new data. But the code part, we don't need to do the code part, right? In fact, there is conversation that software development as a whole, probably be the biggest industry that will be really disrupted by AI, by Gen AI already, and we'll talk a bit about that as well. And so, and what's nice about models is that once a model is built, the more data you feed it, the more valuable it becomes, the more accurate it becomes. So more data means more accuracy, more, it just gets better. And so that really, really, like when you look at this, so, you know, traditional ML, I'm using Azure as an example here, right? If you guys have used Azure Machine Learning, which is a service or resource running in the Azure cloud, you'll see that it gives you a bunch of options, right? It allows you to do, classification, regression, and clustering. And so classification and regression are really where, it's supervised learning, where you actually have to label the data, or you have to tell the machine or the bot or the agent. Those are all three wonderful terms that you can describe your AI overmaster in the future with. And so that is the data that we label it with. So classification, you want to do single class, you want to do multi-class, right? How many, and that could help us sort of look at the different classes, what class it falls into. A great example of classification in the healthcare domain I work in is it can be used to predict, let's say, if somebody has these, if somebody has all of these diagnostic values, right? Maybe their blood type, their, whatever, blood cell count, their insulin level, their, whatever it is, the thickness of their skin or something. It can predict, let's say, if someone's going to have a disease or something, or maybe something like that. So that's kind of where it lends itself. And then regression is where, regression is used constantly, especially in the stock market world. Hey, where's the stock price going to go based on these series of patterns and so on? So predicting those numerical values and so on. And then clustering is when you have, sorry, give me a second. Something just popped up. It was my AI agent that popped up. So, and then you have clustering where you basically divide, the groups. Maybe we don't know how to divide and categorize different populations. Maybe this is folks that are coming into our e-commerce store and looking and buying, and we want to cluster them in based on their what are they clicking, what are their buying habits, their patterns, and so on. That's is customer segmentation. So all of these 100% based on data. Now, one thing to note here is the data set is very narrow, right? And that's really the key here that I want to highlight is this these kinds of data triggers off a bunch of things for us. we start using these in Azure. As you know, in Azure, when you go in, if some of you have used Azure, it's a lot to take in, right? So Azure made it kind of easy for us, where they've said, hey, here's a cheat sheet that tells you exactly what you want to do, when you want to do it. You can start looking at where in that sort of um, timeline where you're, what kind of workload you want to run, right? And based on that. So we're not going to go into this, but this is just something for reference here within Azure. Um, and typically, if you double click into that, it asks you, hey, what do you want to do with the data, right? Basically, before you even get to the cheat sheet, what do you want to do with the data? And then do you have any requirements on, you know, accuracy, the training time, the training time will also depend on the cost you want to spend in, because, anything in the cloud costs when it comes to compute cycles. So what kind of compute cycle do we want to go GPU, CPU, or what kind of GPU or CPU flavor we want to bring in, right? So all of these are very important. And this has been the traditional algorithm selection. So what we're getting at is that there's a lot of work to get in to building out any kind of traditional machine learning workload, right? And so, in fact, several years ago, I worked for a company and we were building machine learning models for folks, and we were charging millions of dollars because it was so brand new back then. It was so on. I think it was like $5 million per AI project or something. It's like ridiculous, So obviously, only a handful of companies could have that kind of budget and spend that kind of money. But what's happened now, and very excited with Gen AI, is the value of Gen AI is introducing AI to the long tail, right? It's really bringing that into the long tail of folks where, traditionally when you look at analytics today, let's go way back in time in the 90s, right? Oh, I've got a balance sheet. I got some transactions from my store. Great. That's historical data. Over time, I'll position that historical data into a data warehouse, and I'll run data warehousing, and I'll run some kind of business intelligence or BI tool on it to get queries to ask, hey, how many sales did I make of this widget X in the last 3 months? Or, we just had, Black Friday and Cyber Monday and Cyber Tuesday, right? So, and maybe Cyber Wednesday happening for some of us. And so, how does that, what were the sales of widget X? Now I'll divide that by regional and so on. So that class of analytics, that was more of descriptive analytics and so on. And then using that, could we predict what the future would look like? And that's kind of where we've played in the last, several years or decade or so. Now going into the future, where you have more like, hey, what should we really do? We get it, we have the data, we get it, we can predict some things, but what should we really do? The inference, right? The cognitive inference of that is something that we ask through prompt-based methods to generative AI tools like, ChatGPT is a perfect example of that. By the way, this was not made by ChatGPT, as some of you may have will ask that question in my last webinar. Was this presentation made by ChatGPT? I'm kind of like, well, not really. You can make a presentation on Gen AI, maybe on descriptions, but then we want to bring in the different topics and everything. So, and the topic is too new for Gen AI to help, right? The training is cut off. That's the joke there. So anyway, so getting back, where Gen AI plays a role, as I mentioned, it helps the long tail. So essentially what we're saying is Gen AI, because it covers several areas within AI and then a natural language progression, it can quickly reduce the technical burden to deploy AI into the enterprise. And that's really what it comes down to. So you no longer have to spend millions of dollars. You no longer have to just hire a data science team. Every individual could generate using Gen AI technology today, could leverage AI in their workspace today. So that's just something wanted to put it out there. And so from an example here, right? What one of the key things for us is when we look at the current level of adoption of AI, right? AI has had, many, I would say uh, it started with Google, and we'll cover a bit of the timeline here in a bit. But really, it takes existing artifacts that's already there, and it generates new artifacts. In fact, there's this concept called hallucination, right? You say, is your AI hallucinating? Meaning that you've given, it's been trained on a bunch of data, now it's making up stuff, right? I recall there was in the early days of Gen AI, there, which was literally 2 years ago, there was a guy that, a lawyer that wanted to use Gen AI to build out his contract, and he did that, and they found that the con the AI basically built a bunch of clauses that were not based on any precedent or anything. It made up law, and so on. So that was the funny thing about that. And so that was the basis of what started, you know, this conversation around hallucinating and Gen AI. And then when you double click into Gen AI, we come across this thing called foundation models. Now these are models that were trained on a large, broad set of unlabeled data, and they were fine tuned for a wide variety of applications. Companies like Azure, Microsoft, like Google, like Meta, formerly Facebook, Amazon, right? All of them have built their own foundation models, and there was an arms race, and there still is an arms race to building out the new best foundation models. And then this itself was then trained on vast amounts of text to interpret and generate human-like textual output. And then an interface was created, and that interface was a service like ChatGPT, as an example, that incorporates a very simple conversational chatbot with the LLM, the large language model, to create that content, right? So that's kind of where we ended up. And so, the term generative AI has been gaining momentum for researchers, companies, and practitioners, right? And so this generative capability, we could see this as an extension of other existing types of AI techniques, right? That are more oriented to either describe, predict, or prescribe different data patterns or optimize specific scenarios, right? Or any kind of advanced AI techniques. And so one of the things is an example here, but just to show you, all of us have either played with ChatGPT or know about ChatGPT. So just as an example is, hey, write a prompt for an ice cream shop. It comes up with an answer. Then we have some code here. This is actually some SQL code that's been deployed here as an example to create a response that we could actually put in as an API request as a REST response as well. And then we have a simple prompt, and this you can hand to your kids. My kids come up with very creative prompts and generates many creative images as an example. So all of this is being generated out of the fly. And so as you can see, from a technical point, these models, they work in very particular way. Instead of just predicting a certain pattern for a data entry, that is, hey, maybe I'm forecasting, what's the dollar value premium for an insurance client, right? They generate several outcomes to a specific instruction, right? And then the interaction with that generative AI model happens on a question answer fashion, right? And this includes both instructions from humans and so on. And so there's this new term called prompt engineering. I don't have a slide for prompt engineering, but this has recently emerged where you're talking context to natural language processing, NLP, and sort of the development of that language model, right? And prompt engineering, basically all it does is, hey, give me the instructions and the input, and then that you want to see the desired output for, right? And in this prompt engineering, we have all these little hacks that pop up on my LinkedIn every day. Hey, use the right wording, right voice, right tone, right structure, and context to guide your model towards generating the desired response in completing a specific task. There are ongoing efforts to develop systematic approaches for designing effective prompts, fine-tuning models for specific tasks, and so on. And how might we mitigate the biases or any of these undesired behaviors, right? So that's what a prompt is, right? So an example would be, I could use this to create new code. I could use this to create new lyrics or melodies. I could use it to create new images, audio, and video, and I could use a language-based prompt as an example. And these are sort of the current capabilities. Obviously, a year from now, 10 years from now, all of this will change. 5 years from now, it will change substantially. Maybe we will finally invent telepathic prompting, where you come up with some way and your brain waves connected to the latest neural net, it will create that image already. And so, an example would be, hey, I'm going to give it a prompt, right? Let's say the prompt is a question and the answer is the completion, right? And so the term completion in the context of natural language processing and language model refers to sort of the generation or the prediction of that text, right? And that completes the given prompt or input. And as a result, this is sort of becoming more widely used by obviously OpenAI's GPT and so on. So in language models, what's emerged is this new field of language modeling, right? Where you're reflecting the ability of models to generate or predict text that fills in or completes a given context or prompt, right? And so this is really what AI is. It's really, just to summarize, a new kind of AI. Its main advantage is its ability to be widely adopted because it's very simple to use, and its ability to enable communication between end users, and generative AI models via a natural language prompt and completion, right? So that's a complete game changer, and so on. So let's look at some of the things that it could be used for. But before that, what I wanted to do is just maybe briefly talk a bit about, sort of the timeline here, right? And so this is really interesting. We've already talked about Microsoft and OpenAI. We'll double click into their thing as well. But you know, so let's start with the initial player. So OpenAI, probably the most key actor in the generative AI wave in 2022 to 2023. It's not open from an open source perspective. Most of their code is proprietary, but they also subscribe to open source projects. But they're a great enabler for everyone to adopt generative AI technologies and so on. So they're basically an AI research lab. And as a company, it's known for developing very advanced natural language processing models. So OpenAI's origins can be traced back to like probably even 2015. Right, it was basically a nonprofit founded by obviously Elon Musk, Sam Altman, who's always in the news lately, and a few other folks, right? So their mission was basically to ensure, hey, do we have the right, we want to ensure that, AI benefits all of humanity. In fact, they went and said something called artificial general intelligence, AGI. There's a book by Bostrom called Superintelligence, which highlights the three flavors of AI. You have narrow AI and sort of average AI, and then you have super AI, right? Or general intelligence AI, right? So general AAGI is like when you have like an AI that is kind of sentient and conscious in a way to make its own actions and things like that. So obviously we're far away from that, given where we are with hardware and so on. The bits have caught up, but not the atoms, right? That's kind of the thing. And so OpenAI and basically created a for-profit subsidiary called OpenAI LP. This basically allowed it to secure funding for some of its ambitious projects. And you need funding because the amount of compute cycles for this. I read an article. OpenAI has about like what is it, X million, 10 millions a day it spends on training and something ridiculous. So obviously that was crazy. So, OpenAI, it basically wants to build these cutting edge models. And so they built a conversational GPT model. It's their most famous, chat GPT application, right? The word GPT actually has the word generative in it. It stands for generative pre-trained transformer, right? This is the state of the art language model. It's known for its ability to generate human-like text and engage in conversational interactions, and so on. And then within this model, we had various different flavors. You had GPT 3, you had GPT 3.5, we have GPT-4, now we have GPT-4 Turbo, GPT-5 Turbo. So, right, so all of these come in. Then we also had something called Whisper, right? This is the next state of the art, right? It's again available through open source repository. If you go to OpenAI and type API, you'll see they've made their Whisper models available. You can also get the Whisper model via Microsoft Azure. All right, so the next actor is sort of Microsoft, right? So where's Microsoft in all of this? They recognized very early on that, you know, OpenAI technology is very disruptive. It's bringing AI to the masses, and so on. So obviously, Microsoft wants to get it, they want to empower every person and organization on the planet to achieve more. So that's kind of in line with what they wanted to do. And so they started building all of these wonderful tools for OpenAI and so on, and so on. So now going back to our traditional AI versus foundation models, think of this very simply. Your traditional AI models, machine learning models were all one model per task, right? Very specialized and so on. Whereas these foundation models, such as LLMs, these are basically ones that are started that combine several of these narrow models and bring them all together under one roof. And then that gives birth to multimodal models, right? Where you have a model that can do basically anything like speech, language, music, image, audio, text, all of these come in. That's what the word multimodal means. And so the partnership between Microsoft, OpenAI, it started building um, you know, several key kind of thing. It started in 2019. I think Microsoft made an announcement, hey, we'll give you $1 billion, and they did a bunch of things with that. Fast forward now, Microsoft has created their own service called Azure OpenAI service. It's not only a part of the Microsoft AI service, but it's part of the Azure AI Suite, right? So, and then within this suite, it's considered as a platform of a service offering, right? Where you can do many, many kinds of offerings, right? You could build out your own code. You with Codex, you can customize with DALI. You could build your own images, and then you can use ChatGPT like thing. In fact, you could take ChatGPT, create a version of ChatGPT like private GPT for your own enterprise data and build it in. So you can customize your own LLM for that as well. And a lot of companies are going to do that. And we if we had more time, we would definitely jump into it. But I know we're running out of time, but I want to jump in and say, quick note here on some of the key questions that come up is, OpenAI versus Azure AI comparison. Guess what? You can do everything that OpenAI can do, but you bring in all the bells and whistles and security and management, administration that AI allows. Obviously, your own data, you have to bring that in. In fact, within OpenAI services, starting from the left, we have a bunch of things from Turing, rich language understanding of ability to translate 100 languages. So these are all narrow, smaller models that have all been added and aggregated into OpenAI and so on. Um, and obviously, we had the traditional cognitive services. When someone asks the question, hey, Microsoft already had cognitive services, how does this change? Well, cognitive services are more narrow focused. And if you want to use something which is a multimodal, which uses all of them together in some fashion, use the Azure OpenAI service, right? And build that in. And so on. So you have an example of, narrow focus versus broad focus, general focus, right? And so on. And so some of the use cases within OpenAI, you could do content summarization, generalized personalized UI for or copy for your website. You can tell it, hey, talk in the tone of maybe one of my favorite podcasters, Andrew Huberman, and create like a medical transcript of just saying, sorry, Andrew, don't come after me, but just saying that OpenAI can take the tone of someone famous and build out content like that, or maybe your favorite Marvel character, right? At the same time, you can feed it content, you can feed it documents, and help summarize it. So, that used to be my old job working in an investment bank 25 years ago. I would summarize newspaper articles and things like that. Well, guess what? AI can do that now. And then code generation, right? You can generate code. You give it some, hey, generate me some Python code, some JavaScript code, and so on, and it will do that. Even semantic search for a particular product, maybe based on image. You have Google Lens as an example, right? So all of these really help. Again, I'm just using this as a reference here. I'm not really going in. What I really wanted to highlight here, guys, is there's basically, you have two options. Either you can use the more available OpenAI Studio, which is you set it up as a resource. You set up resources in Azure Portal many, many times, portal.azure.com or oa.azure.com, and you can set up a studio or a playground, and so on. To do that, you have to get access. So there is a separate access. Microsoft today does not allow anybody to come in. You can't use it for personal. You have to log in with a customer facing or your facing, like your enterprise corporate email address, and using that to log in. Or and then it takes about 24 hours to get it, and so on. And at the same time, the pricing for OpenAI typically will be similar. Microsoft and OpenAI, they use the same pricing model. It's tokens. You know how many tokens of compute cycles and so on, per second messaging you could use, and so on, that you could use. So that's sort of our recap here. Our Gen AI is here to stay. It's the easy button for your AI implementations. Definitely leverage that with folks. So if there are any questions, but I do want to put out here, we're looking for new topics. And if you think generative AI is something you want to jump into, we didn't get enough time to do our portal demo. We'd love to do that in our next session, maybe. OpenAI architectures, maybe another topic on prompt engineering. So I'll pass it off to you, Peter, if there's any questions in the Q&A.
Yeah, we've got a here, and like Zaki said, drop any other ideas or questions in the comments, and we'd love to get those. First one we have here, are the OpenAI tools available on Azure? I know we specifically talked about Azure, but I assume those are used.
Yes, they are absolutely. Whisper is available, as well as OpenAI itself is available, as I mentioned. Yeah, so they're all available.
All right, sounds good. And the next one we had here, how is Azure OpenAI billed, or is it included with your Azure subscription?
It is included with your Azure subscription. So it will ask you either, quick note, the word token, right? So generative AI has adopted the notion of tokens, which is a set of words or characters which we split. When you take a text, it will basically, that's the consumption model, right? So OpenAI follows the same unit pricing. So it's based on the cost of 1,000 tokens, right? So and then there are token limits for each one. So I know and you can look those up. Then your subscription, when you set up your subscription for OpenAI model, you'll have to basically select what type of service quota you need for that. How many tokens. Typically 16,000 tokens is great. General rule of thumb, 1,000 tokens is equivalent to 750 words, so.
I have a lot of tokens left from an arcade. Would those work? A different kind of token. All right, looks like that's it on the question side for now. But if we do see anything pop in here in the last as we close up, I will. But did want to let you all know about a couple of courses that might be helpful as you go down this path. One of our courses called Designing and Implementing a Microsoft Azure Solution, which is AI 102 is a place to get started. The 4-hour course having the necessary knowledge for designing Azure AI solutions by building a customer support chatbot. So you actually get hands-on practice. So that course is only $30. So I'll drop a link to that in the chat. And if you're just testing the waters, you want to take a look at some of our content. We have a free Introduction to Machine Learning course. So that way you can kind of see the teaching style and see how it works. And if you want to take next steps with some other training, so I'll links in for both of the as well, which I've just done, so you can take a look at those. So, Zaki, any thoughts before we close up here?
No, I definitely encourage everyone to definitely go in and sign up for the next series of webinars. I think the verdict is unanimous, Peter. We probably will have some more Gen AI topics given the interest here on folks. So do stay tuned for what those topics are, and look, good. Have a good rest of your day, guys.
Yeah, I know we're looking at. I think we said this 13th for our next one.
That's correct, December 13th.
So, yeah, we'll probably do something along these lines again, based on the number of registrations and things. And thank you for the applause there to the LinkedIn user. But thank you, Zaki, so much for presenting. Thank you all for listening, both live and recorded. And we hope to see you next time.